So 2 p.m. last talk of the session. Thank you everyone who's here. Let's keep it short. Title of the talk is DC-SCM Threats and Mitigations. If you're at OCP, you should know what DC-SCM is. If you don't know, then we want to have a discussion. What have you been looking at that you don't know? But let's, I'm Andres, right? I gave a talk just a little while ago. So we'll go through like a 10-second crash course. It's a standardized OCP modular architecture where you separate the motherboard with the CPU and the DIMMs from a secure control module where you put your hyperscaler super secret sauce. In other words, a card with your favorite BMC and your favorite platform root of trust. So there's a standard for the HBM, formerly known as MOVO. There's a standard for this SCM card. There's a standard for the interface between the two, SCI. Right? So the idea is that the white labels who make these machines, they're going to just make one MOVO. And they're going to isolate all the fancy differences between different customers in one tiny little card. There's also a potential ulterior goal, which is to allow the control card to be reused for different motherboards, right? So this is a drawing from the 2.0 spec. People are talking, you know, on the server track, on the hardware management track. You will see all these drawings. You will see all of this. Basically, this presentation has 6 or 7 slides that keep going back to this particular drawing. There's nothing inherent here about there being 2 CPUs on the mobile side. That one doesn't really matter. It's just the drawing that they had. What matters here is the things in the DC-SCI and the paths between them, right? So we're posing to you at this moment an oxymoron that we want to double click. You know, is the secure control module secure, right? Of course, there's a TPM in there and a platform root of trust, and all these chips are about security, but there are other problems, right? There's 2 family of problems that we have with this architectural change that we need to address. One family of problems is that a standardized interface makes for standardized interposition. I believe Jeff talked about that earlier this morning. The other family of problems is that this card has a lot of privileges, right? It's running the BMC, it's running the platform root of trust, it may have TPMs. So it can, and it's swappable. So you can put it here, and then you can take it there, and you can mount confused deputies attacks that way. So let's double click on the problems, right? Interposition. The thing to keep in mind here is that when you have large scale deployments, physical security is not gonna get you confidentiality, right? Hyperscalers, of course, we have cages and metal detectors and cameras and guards and all that stuff. All that's great, but that's so that people don't just walk away from the data center with equipment. That's what that primarily is about. It's not a good mitigation against confidentiality threats, right? So physically securing every asset is just not tractable against attacks where people are just walking by and swapping something and then walking away, right? Or plugging an interposer and walking away. Although we make our best, we'll need to think that those attacks are essentially at very large scales, those attacks are very hard to defeat. And there's, of course, there's thousands of personnel all over the world, all kinds of jurisdictions, all kinds of problems and vectors that happen there. So I think this point was made earlier today. Now you have a standardized interface, right? So in the past, you might have needed to desolder to get in the middle of some of these paths. Now there's just a plug. So you plug something in the plug and you're done, right? You can, at home, you can device your gizmo and then you just go and plug it. So what are the threats here? Why do we care? I mean, yeah, sure, you can plug on a power line, no one cares, right? That's not the problem. I want to bring attention to 2 main problems. One is JTAG, the other one is SPY. The reason why we care is that an availability attack by using physical means is not something we really care about. So what? You walked up to the machine and the machine doesn't boot anymore? No one cares. You did walk up to the machine. You could have just kicked the machine in the teeth, and that would have been all. What we do care about is if you get at user data. Even one instance of that breach is, of course, a big deal to that user. It's a big deal for us. It's a big deal for reputation and all those things. So which ones allow you to get to user data? Of course, the SPY bus. We've talked about this. That's your boot code, right? with an interposer, you can define what boots on the platform. And you can do this without the root of trust being none the wiser. So that's a problem, right? You can essentially bypass everything that way. The other one, of course, is JTAG. JTAG, we like to talk about root capabilities, then we like to talk about root in the kernel, and then, but there's another concept which is root in silicon, even below the kernel. Like, can I literally see your registers? Can I dump your microcode and decode it, right? Those are tremendous, phenomenal capabilities, and JTAG can give you those capabilities. And of course, there are 4 JTAG pins in DC-SCM. Please insert yourself here, go, right? As well as the SPI pins. So we really care about those because they give you control over execution and control over confidentiality. So some thoughts on solutions. So the first point, I hope it's made. This is a great initiative that we have in OCP, but it opens the door to new threats or existing threats made easier, right? So some thoughts on this. Essentially moving the trust into the CPU. That's the main pattern here, right? So if you look at the solutions being proposed, CPU side JTAG authorization. Think about it this way. In the data center, at scale, somebody's going to tap those 4 JTAG pins, one way or the other. And it's going to be somebody who gains control of a BMC that is logically connected. It's going to be someone who uses an XDP header. It's going to be someone that uses DC-SCM. Somebody's going to get there. So you need to have CPU-side JTAG authorization, something that says, those shall not pass, completely controlled by the CPU side. These things exist in some scenarios. We would like them to exist in all scenarios for all devices that use JTAG. And of course, what we've been talking about quite a bit today, you want to move the root of trust for measurement into the package, away from the interposer, away from the board, away from the buses. In that scenario, no matter what they interpose, no matter what gizmos happen, no matter what goes on SPI, still the RTM is going to be able to tell you the truth about it. Outside of this threat model is, okay, they decapped the package and are messing with the package. Okay, that's a different threat model. And that's where we talk about the RTM in the composable security architecture. We talk about Calyptra. That's what's going on there. Earlier today, we had the talk, Defeating Active Interposers with DICE. That talk is very well aligned with this. Right? The talk is saying a DPE, a DICE identity engine on the CPU side can be used to secure that SPI channel, mount end-to-end cryptography, and defeat interposers that way. Moving on. The other broad family of attacks is card swapping, right? I have a super privileged card that I put in the wrong server, or I have different servers that have different privileges for different workloads, and I take the debug card, the debug privileges card into the production super secret server, right? So you can infect multiple systems that way via swapping. This is all physically present adversaries. But again, the point of a physically present adversary for us is not denial of service. They are physically present, but their potential ability to gain more execution and confidential controls that we might have thought of. For example, you put the wrong SCM with evil code into a highly privileged machine, and you bit bang a CPLD, and now you're living in that CPLD in the highly privileged mobile forever. That would be bad, right? Remember that the SCM, the Secure Control Module card, carries both BMC and CPU firmware. In some scenarios, this SCM has an eMMC. That eMMC has all kinds of bits in it. And at the extreme, there's a standard interface, right? So you can have an actively malicious, purposefully designed SCM being plugged in your data center. That can happen. So you have to think of this as a card with arbitrary firmware. So what do we allow that card to do on the HPN? Do we allow it to extract assets of the mobile? Do we allow it to persist into mobile state? Again, all of this for physically present adversaries. So some thoughts on these situations. It's really hard in the data center to say, oh, a machine reset, or a machine power cycle, or a machine black hole for 1 minute, or a machine has the wrong card, we're under attack. That's not reality, right? 99.999% of the cases, somebody made a mistake. An operations person just took the wrong card or kicked the wrong cable, right? So it's very hard to say, oh, this is happening we need to take corrective action. In reality, most of the time, the signal-to-noise ratio is terrible for this. So it's not the kind of situation where you would put alerts. Instead, you need to deprivilege the control channels, right? All these things that card swaps could allow you to, that we haven't addressed already here with JTAG authorization, with DPE, all those things, you need to deprivilege them, right? So if you're looking at a design where somebody's saying, oh, over the CPLD, I'm going to have some access to confidential data, that's a no-no design. Other things, BMC. Obviously, the BMC could be completely malicious because a card could be physically malicious. So don't let that BMC DMA into your memory, right? I think we're talking about security best practices, right? And good hygiene. So that's the end. This is a short presentation and that's why it's the last one, right? So follow the OCP security architecture, best practices on attestation, best practices on secure boot. Make sure your CPUs and everything that touches confidential data is running the code that it should be running. Move that into an RTMs inside the CPU. Only authorize JTAG from the CPU side. And follow what Jeff and others have been saying, with Project Kirkland is saying, defeating active interposers with DICE. And of course, best practices. Use IMMU. Don't let random VMCs attack you. Don't run smashable USB stacks. These are all the signals that you get through SCI that we just have to assume, essentially, in a threat model, that are going to be actively malicious. Call to action: make these practices default. Come to our talks. Come to our meetings. So very short presentation on purpose. Just wanted to highlight the seeming contradiction between having a secure control module that lowers security, but it's completely addressable, right? The things that we're building add up to a solution for that. Any questions?
I think there is also other thing that looks like you may have excluded or not included by design. If somebody swaps DC-SCM from one server to other server, in systems where TPM, for example, represents the node ID or the ID for that box, identity for that box, that is potentially lost. Have you?
Right. So again, this is indexing on the active interposers with DICE. It might represent to it, but it's only going to unlock those secrets to the UDS rooted stack on the CPU. So you need both to get the secrets. If you get one or the other, you get no secrets. And that's by design. That's in order to deprivilege, to a large degree, this card. And that's to avoid the card dancing, or to mitigate the card dancing scenarios.
Yeah,
yes, having your entire identity be in the SCM, which is a very tiny card, is potentially very dangerous for many reasons, like you highlighted.
Yeah, I'm talking about the situation where, for example, IDEV-ID, TCG IDEV-ID put into TPM. So that represents the identity for that box, the entire box, not just the DC-SCM.
Yeah, we're saying that's a bug. That's what we're saying. Don't do that. That's a bug. There is an IDEV-ID on the CPU side. Use both. Not the IDEV-ID, right?
Okay.
DICE change.
BMC can have IDEV-ID, CPU can have IDEV-ID.
Yes.
TPM can have IDEV-ID, but all of them representing the same system. So two of the IDEV-IDs, when you swap, are sort of lost, right? They don't exist anymore.
Which is a good outcome, because that swap was unexpected.
Okay.
That's an attack, right? You're saying that the threat is somebody swapped it.
Right.
That's
what I'm wondering is there anything that we need to consider prevent swapping itself to make things easy?
Swapping will happen. Like, if you have hundreds of thousands of machines, people need to fix those machines. Cards fail for good reasons, for legitimate reasons that don't have anything to do with security. We cannot have a repair policy that says, oh, I need to throw away the entire machine because the little card failed. Swapping will happen in practice a lot. And it's a legitimate act, so we need to enable it. Yes.
Okay, yeah, I understand swapping will happen, but I was wondering, do we need to have a way to detect that swapping happened?
Oh, yes, of course.
Then take some remediation actions or some reprovisioning
Yes.
or whatever required.
Yes, so the requirement, detect that swapping has happened, is something that I definitely agreed. And the proposal for a good way to do it is, defining active interposers with dice. Yeah. Thank you for the question.
Thank you for explicitly noting JTAG authorization. It's an interesting topic to me as well. Obviously, authorization means by default there is no access to JTAG.
Yeah.
Now, if the authorization is done via software, not by the hardware, that could lead to a situation where, for failure analysis, we want JTAG to be unlocked, and yet software may not be loading because of failure analysis scenario.
Mm-hmm.
Have you had thoughts on this scenario?
Yeah, I mean, there are many thoughts. I don't know that there are any solutions. So there's a number of scenarios here. I think one of the things that we like is, okay, I booted this system. This system will never enable JTAG. That's a very powerful property, particularly as you move into a world with confidential compute and SCV, SMP, and TDX. All the TDX in the universe is completely voided if underneath you can go to the cache lines via JTAG or the registers, right? So I think we want a world where there's this scenario where it booted with JTAG off forever. Of course, that moves all that trust into the CPU implementation, but it's already there, right? But there's an obvious trade-off, right? If I have a stack in that machine that it's hurting, I cannot debug it at that level, right? So volatile dynamic unlock of JTAG is super scary. That's all I want to say right now. I'm happy, we're happy to have more conversations about it. But in the middle of operation, there's a system that is hung, and you want to go and volatile unlock it. Yeah, I think it's a hard trade-off for security, but it's one we need to find a way to deal with. Yeah.
Okay, thank you. Another related question on authorization, just like we have dual signing or ownership transfer concepts, if the key for JTAG authorization is owned by the silicon vendor, that sort of blows a hole into the whole security model around ownership transfers. So how do you envision the key for JTAG authorization to be owned?
I mean, it's an endless topic, right? You could do some sort of transfer of ownership for the authorization. It kind of hits straight into circular economy. You take ownership of an asset, you want to rotate the JTAG authorization keys alongside other things that you're rotating. Okay, you have limited slots. How many times do you resell it? So that it's a world of trade-offs, right? What I think is happening right now, or at least our experience, is the JTAG volatile unlock is in the vault of the supplier, and it gets trotted out only in complete emergencies. But I think it would be very bad if those are global keys. And I hope all the suppliers are doing the best practice of having per asset keys, right? So only one, you get a breach and only one thing can be unlocked. But anyway, we're kind of straying away quite a bit. These are very good questions. Thank you. All right, Jeff, do we call it? Yeah.
Thanks for all those amazing talks.